close your eyes for 5 seconds. Go ahead. Do it now. Done. Good. In those 5 quiet seconds, you traveled roughly 3,000 kilometers through space. Yes, 3,000 kilometers. And you didn't move an inch, and there were no rocket engines or wormholes involved. The reason? Something out there, invisible and incomprehensibly massive, is pulling you toward it. Right now, as you sit here, breathe, and watch this video, this enormous force has been pulling you your entire life. It was happening before you were born, before humans even existed, before the Earth formed, and before the sun ignited. This force has been dragging the entire Milky Way galaxy with its 200 billion stars, all the planets, and even the dark matter toward a singular point in the universe. All of this has been happening at a speed of over 600 kilometers per second for billions of years. But we only discovered it in 1978. Welcome to the Great Attractor, a mysterious gravitational titan lurking in the cosmos, an invisible giant nobody really talks about, the very thing that's currently swallowing entire superclusters of galaxies. Today, we're diving directly into its heart. Before we get into the thick of things, if you find the universe as terrifying and beautiful as I do, hit subscribe now and smash that like button. It helps this channel continue making these deep dives, and trust me, you'll want to stick around until the very end. What scientists recently discovered beyond the Great Attractor is so much bigger, so much stranger that it rewrites everything we know. So let's get started, and I promise you'll be on the edge of your seat. Let's talk about motion. In space, nothing is ever still. You know that the Earth spins, orbits the sun, and the solar system revolves around the galaxy. Scientists had mapped it all out, the entire universe. But something was off. In 1978, a team of astrophysicists stumbled upon an anomaly, the Milky Way, and hundreds of other galaxies were moving in a way they shouldn't. They weren't drifting apart as expected. They were being pulled at a speed of 600 kilometers per second toward a hidden point in space. This point is located beyond the plane of our galaxy, in the direction of the southern constellation Norma. For context, the fastest spacecraft humanity has ever built moves at just 18 kilometers per second, but the Milky Way is being dragged 34 times faster than that. This revelation rocked the scientific community. What could possibly exert such a powerful gravitational pull? The mass required for something to do this had to be unimaginable. Early estimates suggested a concentration of mass around 10,000 trillion times the mass of our Sunday, a number so large it's nearly incomprehensible. And that's how the Great Attractor was born, an invisible gravitational giant with a mass so immense it was beyond human understanding. But here's where things start getting strange. The Great Attractor lies between 150 million and 250 million light-years away from us. That's already a mind-boggling distance. To put that in perspective, light, the fastest thing in the universe, would take a minimum of 150 million years to cross this vast expanse. Yet, we can't simply point a telescope at it and see what's going on. The Great Attractor lies behind the thick galactic plane of the Milky Way, packed with stars, gas, and dust. This region is so dense that visible light from the other side is completely blocked. It's essentially invisible. Astronomers call it the zone of avoidance, a region that optical telescopes simply can't penetrate. Imagine knowing something massive is pulling you, but being unable to see it. We only knew it was there because of its effect on us. We were being dragged toward an invisible force, unable to even observe it. It wasn't until the late 1990s, using X-ray telescopes that could pierce through the Milky Way's obscuring dust, that astronomers were finally able to glimpse the heart of the Great Attractor. And what did they find? The heart of the Great Attractor region revealed itself to be the Norma cluster, also known as ACO 3627. This is one of the most massive galaxy clusters in the observable universe. It's an ancient collection of galaxies with hundreds of enormous elliptical galaxies packed tightly together. Many of these galaxies are in the process of colliding, causing slow-motion cosmic crashes that unfold over millions of years. These collisions generate enormous amounts of radio waves, which was one of the first clues that something extraordinary was happening in this region. But the Norma cluster is just the visible anchor of the Great Attractor. To truly understand it, we have to think of the Great Attractor as a gravitational focal point, a meeting place for massive cosmic flows. Imagine water swirling toward a drain in a bathtub. The water from every corner of the tub flows toward that single point. Now, imagine, instead of water, it's galaxies, and instead of a bathtub, it's a sphere of space stretching 500 million light-years across. This is the Laniakea supercluster, and the Great Attractor is its drain. In 2014, astronomers mapped the entire Laniakea supercluster and named it after a Hawaiian word meaning immeasurable heaven. Laniakea contains around 100,000 galaxies and spans a vast 500 million light-years. The Milky Way is located on the outer edge of this colossal cosmic structure, caught in the gravitational flow toward the Great Attractor. For the first time, scientists could visualize these enormous rivers of galaxies, these cosmic flows stretching across hundreds of millions of light-years, all heading toward the same gravitational point. This discovery opened our eyes to the immense, unobservable forces shaping the universe. But hold on, here's where things get even stranger. The Great Attractor itself is moving. As scientists refine their measurements using powerful X-ray surveys and better techniques to map the cosmic flow of galaxies, they realize something remarkable. The Great Attractor isn't the ultimate destination. It too is being pulled towards something even more massive. This massive structure is known as the Shapley supercluster. Discovered by astronomer Harlow Shapley in 1930, the Shapley supercluster contains dozens of galaxy clusters and sits about 650 million light-years away from Earth. It's one of the most massive concentrations of matter in the observable universe. Here's the chain of cosmic events. The Milky Way is part of the local group of galaxies which is caught in the gravitational pull of the Laniakea supercluster. Laniakea is falling toward the Great Attractor, and the Great Attractor is falling toward the Shapley supercluster. It's like a set of nested gravitational nesting dolls, each one pulling the next closer. The Great Attractor was never the final destination, it was just the first step on a long cosmic staircase. And what lies at the bottom of that staircase is so massive, it makes the Great Attractor look like a footnote. So, what happens if all these galaxies are being drawn toward the Shapley supercluster? Will they eventually collide? Will the universe collapse in on itself? The answer is no, and it's because of one of the strangest and most counterintuitive phenomena in modern physics: dark energy. Dark energy is the mysterious force causing the expansion of the universe to accelerate. It's not just expanding, it's accelerating. Every second, the universe is expanding faster, pushing galaxies further apart. Despite the immense gravitational pull of the Great Attractor, the universe's expansion is so rapid that the Milky Way will never actually reach it. We've been falling toward the Great Attractor for billions of years, but the universe is stretching so fast that the Great Attractor is simultaneously moving away from us. Eventually, in the distant future, the expansion of the universe will stretch space so dramatically that the gravitational influence of the Great Attractor will fade. The Milky Way will drift away and will no longer be falling toward it. This is one of the most humbling aspects of the universe. A journey that has been ongoing for billions of years, yet the destination is unreachable. The Great Attractor's gravitational pull is immense, but because of the expanding universe, it will never be reached. It's an existential paradox that raises profound questions about our place in the cosmos. Now, imagine standing at the heart of the Norma cluster. If you could see it, you'd witness one of the most violent and spectacular environments in the universe. The Norma cluster is filled with ancient massive elliptical galaxies, many of which are colliding with one another in slow cosmic crashes. The space between them is filled with gas, heated to millions of degrees, radiating in X-ray light. It's a chaotic, beautiful mess, and it's all being drawn toward the Great Attractor. But here's the kicker. The Laniakea supercluster, the very thing that anchors the Great Attractor, is not gravitationally bound. It's too large, and the expansion of the universe is too strong. Eventually, dark energy will tear apart the galaxies within it. In billions of years, astronomers will look out at the sky and see only darkness where the Laniakea supercluster once was. The Great Attractor's influence will be gone, and the galaxies will have drifted beyond the observable horizon. Each galaxy will be isolated, left alone in the vast emptiness of space. It's a humbling thought, but for now, we remain part of something magnificent. We're riding the cosmic river toward the Great Attractor, and while our destination may forever recede, we're still on a journey we didn't even know we were taking until we began to understand the forces at play. If this video has made you think differently about your place in the universe, hit that like button and subscribe. It costs you nothing and helps us continue these deep dives into the mysteries of the cosmos. New videos every week. Let's explore the universe together.